Everyone. I'm here to present you a new open source project that I'm working. So it's an open source project and a course that I'm developing to teach convolution neural networks for developers. So this project will be walking through a few important concepts to understand how CNN works. So we are going to be playing a lot with deep learning, but we'll be focused on the images and the convolution neural networks. We are going to be starting this journey looking at how to manipulate images with NumPy and Python. So we're going to be seeing how image is represented in an array of colors, and I'll be doing some small transformation as well, and this will give a good understanding of what is the image and how to manipulate it. Then we're going to be looking at convolution itself. We're going to be playing with some kernel filters and seeing how we can extract features from an image and highlights important characteristics of this image that will help our neural net to learn more about the images. Then we're going to be looking at how to implement from scratch a backpropagation algorithm, which it is used in the neural nets by the frameworks like TensorFlow and PyTorch. And with this implementation, we are going to be learning everything that is behind a deep learning architecture. So we're going to be looking at some important concepts before you start the implementation. So for example, how dot product works, matrix multiplication. Then we're going to be also seeing some derivative, gradient, and how that is used in the deep learning model, and how learning rates works, activation function. We're going to be looking at all that, and then we're going to be building our neural net and put it for training with this data set of numbers. And everything here will help us to understand what is under the hood of deep neural network frameworks. And then we're going to do the same, create the same model, but this time using PyTorch. And this way we'll be comparing our implementation with PyTorch. And when you working and professionally with frameworks, you're going to be understand what is behind every step of the model creation. And then you're going to be looking at playing specifically with convolution neural network. We're going to be building an image classification problem, and we will be looking at some important concept and playing with PyTorch to solve this problem of convolutions. And everything here will be very descriptive. We are going to be looking at some architectures as well, and then we are going to be playing specific. We are going to be developing a MultiTask model and with transfer learning. So it's very important techniques to speed up the training process. And MultiTask, it's very it's important when you have multitasks and you don't want to, and you try to speed up things using the same model. So for example, here we're going to be using the same model to identify the gender and the race of a set of people based on this data set. Then we are going to be looking at some image interpolation and play with autoencoders to achieve that. So we're going to see how to extract some feature map information about the images, and from there we are going to be playing and create some interesting things like image interpolation, for example, going from the number 1 to number 7, and how you get the intermediate part of it. And then you'll be using that to generate some numbers as well. And then you're going to be with those latent space, you can create some image search engine as well. So you give one image, you can get retrieve all the similar image in our data set. For example, here I'm passing the number 7, and we are going to get all the number 7 from our let's say library. And then you're going to be looking at guns and how we can use deep learning to generate fake images that it's very realistic. And I think there is a lot of valuable information here, and this course and project is pretty unique, so you don't see much example focus on convolution neural net from the let's say from the very basic until advanced example. I hope you guys enjoy, and see you in the lectures.